Imagine a world where computers could solve problems that are currently impossible, where medicine could be personalized to each individual, and where materials could be designed with unprecedented precision. This is the promise of quantum computing.
In a recent article in The Hill, Sam Howell, a research associate at the Center for New American Security in Washington, D.C., writes, if countries are serious about climate change, they should get
$1 investment to help build a world-first commercial-scale quantum computer. For more, we're joined by the Minister for Industry and Science.
Will be done 100 million times faster, which is quite mind-blowing.
Universal quantum is a start.
Previously, we launched this brand new channel, Quantum Pieces, where we're breaking down quantum computing like it's a puzzle you can actually solve without a PhD. We've already tackled the basics, and now we're diving into the heart of quantum computing, qubits. You can think of a qubit as a tiny, versatile superhero of the quantum world. It's like a coin spinning so fast it's both heads and tails simultaneously, blurring the lines of reality. This mind-bending phenomenon is called superposition, and it's the key to unlocking the immense power of quantum computers. Imagine a computer that can explore a million possibilities at once, like a million brains working in perfect harmony. This is the power of superposition, the topic we introduced in our previous video. It allows quantum computers to tackle problems that would take classical computers billions of years. However, don't get misled, quantum computers could be better than classical computers in many ways, yet they can't do many things that classical computers can, and it is irrelevant to call quantum computers better than classical without mentioning the operation on which they are compared to. Sadly, these quantum superheroes are delicate, like snowflakes in a hurricane. Anyway, superheroes are cool, ain't they? Talking about cool, qubits need to be kept at extremely low temperatures, 1/100th of a degree above absolute zero, to avoid decoherence, a process where they lose their quantum properties. Think of it like a superpowered cat that needs a special, temperature-controlled room to stay awesome. Don't think about Schrödinger cat. We haven't reached there yet. So, how do these quantum computers actually work? And to explain the working of quantum computer, we will discuss about few quantum phenomenon which are extremely important. Superposition. The qubits are in their both-at-once state, exploring all the possible solutions to a problem. Entanglement. These qubits are linked together, like a team of superheroes working in perfect harmony, their fates intertwined. The important thing to note is that changes to one qubit instantly affect the others, no matter how far apart they are. And one of the most important topic in wave optics, interference. The qubits both at once powers interact, creating a wave of possibilities that can amplify the right answers and cancel out the wrong ones. One of the examples of these amazing qubits is spinning of an electron. Imagine an electron as a tiny spinning ball. It's not exactly accurate, but it helps us picture it. Spin is like a fundamental property of the electron, like its mass or charge. It's just part of what makes it an electron. And here's the kicker. Spin is quantized, meaning it can only be in specific states, like spin up or spin down. It's like a tiny switch that can only be on or off. Spin has a huge impact on everything from the way atoms are structured to the way quantum computers work. It's a big deal. Now, why do qubits matter? Because they're the key to unlocking the power of quantum computing. They can explore a ton of possibilities at once, giving quantum computers a massive advantage over classical computers. Work together in a way that's impossible for regular bits, creating a powerful synergy that allows them to solve complex problems. Run quantum algorithms that can solve problems that are impossible for classical computers, opening up a whole new world of possibilities. But there are still some challenges to overcome. Building large-scale quantum computers is like building a super-complex Lego set, requiring incredible precision and engineering. Keeping qubits in their both-at-once state is like trying to keep a butterfly in a hurricane, requiring careful control and isolation. Quantum computers are prone to errors, like a mischievous gremlin messing with the controls, requiring sophisticated error correction techniques. But don't worry, researchers are working hard to overcome these challenges. They're like a team of brilliant scientists trying to tame the quantum beast, pushing the boundaries of what's possible. And the future of quantum computing is bright. It's like a whole new world of possibilities waiting to be explored, a world where the impossible becomes possible. So, stay tuned for more quantum adventures. We'll be diving deeper into the world of qubits, spin, and all the other amazing things that make quantum computing so exciting. And remember, keep learning and keep growing. The quantum world is full of surprises, and the journey of discovery is just beginning.